close this section, let's work through another example. Consider the next castle graph with 4 variables, x, y, z, and w, in which we indicate next to the nodes all the possible values that each categorical variable can take, and also show to the right the factorized joint probability distribution according to the causal graph. So, which will be the conditional probability table for the variable w? We start by computing the number of columns. In this case, we have 3 columns, because w can take 3 possible values, 0, 1, or 2. Then, we compute the number of rows, which is obtained by multiplying the number of categories for each of the parent variables of w. In this causal graph, w has 3 parents, x, y, and z, each a binary variable with 2 categories. So the number of rows is 2 times 2 times 2 equals 8. We have 8 rows to lay out all the possible combinations of the parent variables. Next, to lay out the combinations of values for the parent variables, we start by choosing any of the parent variables. Let's choose the x variable and divide the number of rows in the table, which is 8, by the number of categories of x, which is 2. 8 divided by 2 equals 4. So we fill the rows by repeating each category of x 4 times as so. Now we choose another variable of the parent variables. Let's choose y and divide the result of the previous step, which was 4, by the number of categories for the variable y, which is 2. So 4 divided by 2 equals 2. This implies repeating each category for y 2 times and doing it again until we fill all the rows. Finally, for the z variable, we divide the result of the previous step, which was 2, by the number of categories of the z variable, which is 2. So 2 divided by 2 equals 1. This implies filling the rows by repeating each category 1 time and doing it again until all the rows are filled. To finish up, we instantiate the conditional probability table for w by setting values for the probabilities for each row, being sure that each row sums to 1.